Hello friends, welcome to a new Amaze. In today's video I want to give you a practical introduction to LLMOps. And to do that I'm going to use Opik, the open source LLM evaluation framework. Alright, so in today's video, as I was saying, I will show you the basics of LLMOps and I will focus in three basic components, okay? I will show you how to do tracing, that is how to track the different spans, the trace spans of your agentic framework, agentic workflow. In this case, I'm going to use LangGraph, but you could extrapolate this to many other agentic frameworks or even to do your own trace spans, okay? You could build your own solution, but I will show you how to do it in LangGraph because it's very, very easy. And we will see how to build this, how to read the different spans, where you can see very interesting information about the time, about the token usage, etc. Apart from that, I will also like to show you how to version prompts. And this is something that I believe, at least, it's really overlooked. If you take a look at tutorials of YouTube videos about LLMs or agents, they often overlook something really important, which is prompt versioning. Because right now, as time goes by and LLM systems and agentic systems are more prevalent, I believe it's really necessary to start adding versioning to these entities as well. We did versioning with models, with data, with code, of course, and now I think it's time to do versioning with prompts as well. Because if you have if you have written a complex prompt, like for example this philosopher karate card, you will see that it's an iterative process and it takes a lot of changes and a lot of reformatting and a lot of improvements, etc. So I think it's really nice to have these different versions so that you can check the progress and you can even fall back to a previous version, okay? The same as you do with the code. So yeah, I will show you how to do this prompt versioning using Opik. And lastly, I will also show you how to evaluate your agentic systems, your agentic RAG systems, like the one we are building here in PhiloAgents. I'm going to show you how to build this evaluation dataset that you can see here. And this dataset contains like conversation samples of a philosopher and the user, and also how to run the different experiments to retrieve relevant metrics. Okay, if you click here to the different experiments, you will see the metrics that we are computing for each one of the experiments. All right, you can also check it here in the metrics tab. Here you will see the different metrics plotted against the time, so you can see the evolution of your agentic RAG system. Okay, and I will give you a detailed description of each one of these metrics and why we are using them, okay, for this project. Okay, so before we get into the code, it's time for some LLMOps theory, so let's get into it. Alright, so since this is a video about LLMOps or LLM operations, the first question that I believe we should answer is the meaning, the definition of LLMOps. I believe that we could define LLMOps as the following: as the set of practices, of tools, or even techniques that aim to optimize the production lifecycle of a large language model. That's basically it. And we can divide, or we can break down LLMOps into 6 major components. All right, we have the model deployment, we have the data management, the prompt versioning, the monitoring and observability, the security, and the evaluation component. Okay, the model deployment, let me give you one example. So suppose you are fine-tuning an LLM with Ansloth and you need to take the resulting GGUF or the binary, resulting binary, and you need to deploy that model to an LLM inference service. So in that case, you will apply principles or techniques belonging to the model deployment component of LLMOps. All right. Then we have the data management. This is something that we are going to see in today's video because we are going to deploy, we are going to manage some specific dataset. In particular, we are going to manage the dataset, the evaluation dataset for our evaluation step. In fact, the data management in this case and the evaluation component are going to be really related. All right. Then we have the prompt versioning. This is something that I already introduced before. It is necessary to version prompts, similar to what we do with data, with models, and with code. We need to version the prompts as well. Then we have the monitoring and observability. This is related to all the something that I showed you here about the traces. Okay, you need to have the ability to trace and to monitor or to observe the agent's behavior. All right, and that belongs to this monitoring and observability component. All right, you need to check the token usage. You need to check the time it takes for its response to be generated. You need to be able to see if the tools are being called and how they are being called. You need to check everything. You need to observe 100% everything, and the agentic framework that you are using should be 100% transparent to you. All right, and that belongs to the monitoring and observability component. Then we have the security component. This is more related to guardrailing, to privacy concerns, and given that as time goes by, much more systems are going to integrate LLMs into their use cases, security is going to become a really prevalent field. I mean, it already is really prevalent, but with LLMs, we will need a lot of security experts that can prevent for hacking LLMs or for bypassing the rules of LLMs, or maybe telling the LLM to delete all database. So yeah, you can see the point of this security component in LLMOps. And finally, we have the evaluation component. And in our case, this is very important because today I'm going to show you PhiloAgents, which, I mean, it's like a video game, but at the same time, it's an agentic RAG application. So evaluation is really important if you are dealing with agents connected to RAG systems, all right? Evaluation is everything related to getting metrics that can give you an objective impression, an objective information about how your RAG application, how your LLM system performs, all right? And that's basically it. We are going to start with prompt versioning because in today's video, I'm going to focus on 3 of these components. I'm not going to focus on security, and I'm not going to focus on model deployment. This is something that I have already covered in previous videos in this channel about how to deploy, for example, fine-tune unsloth models to Lambda instances, for example. And also I'm going to skip the security part. This is something that I have planned for future videos about techniques to bypass or to hack LLMs, which I think is going to be really interesting. But in today's video, I'm just going to focus on monitoring and observability, data management, prompt versioning, and evaluation. All right, perfect. So let's begin with prompt versioning. You can see here this pretty self-explanatory diagram where you see the first prompt, you are a helpful assistant. This is V1. Then we modify the prompt and you say, okay, you are a helpful assistant, it's okay, but we need to improve this prompt. So let's add talk like Mario Bros. Okay, so this is V2. And finally, V3, you are a helpful assistant, talk like Mario Bros. But additionally, summarize every document you receive. Okay, so we have 3 versions of a prompt. All right, and this is really easy to do in Opik. You will see how I do it. So, well, first of all, before I forget, remember that you have all the code for this series, series of videos in the Neural Maze organization in the PhiloAgents course. PhiloAgents, in case you miss it, is this video game agentic application that both Paul Iusztin and myself have been building for a few months, and right now it has become an open source course. You have a link to Paul's articles because we have written lessons and video lessons. You are seeing the video lesson, and you also have Paul's articles in his Substack. All right, so I'll put all the links in the video description in case you are interested. All right, so yeah, first of all, remember you need to clone this repository to follow this lesson, and after that, to start PhiloAgents, wrong makefile, you need to go to the makefile in the parent folder, okay, to this makefile, and inside just run this make command, okay. Before, of course, you need to start UV, etc., etc. Okay, but this is something that I already covered in the first video of this series. But remember that you have this install and usage markdown with all the information about how to start PhiloAgents. Okay, but yeah, after that you just need to run the make infrastructure app command, and the Docker application is going to start. So if we go to Docker desktop, you will see something like this PhiloAgents course application with 3 services, the UI, and the API, and a local MongoDB instance. Okay, and remember that if you click the UI, if you go to port 8080, you can just start playing the simulation. Okay, this is something that we have covered extensively in the previous videos, so I'm not going to do it again, but I will use this simulation again to show you how to trace the different dialogues. Okay, but yeah, I want to start, as I was saying, with the prompt versioning. So to see how we are dealing with the prompts, you just need to go to PhiloAgents API. This is where the Python API resides. Remember that we have 2 main folders, the PhiloAgents API and the PhiloAgents UI, that contains basically JavaScript code and for the Phaser application. Inside PhiloAgents API, you just need to go to source PhiloAgents, and inside the domain to prompts. And here you will see this tiny class that contains all the logic that you need to version your own prompts. Okay, check here that we are importing Opik, and inside the class prompt, in the init method, we are defining this private attribute, this self underscore prompt, as this Opik prompt class with a name and with a prompt. Okay, prompt is basically the text that we want to use as prompt, and the name is the name that we want to associate with this prompt class when it's deployed to Opik. All right. Apart from that, this class also enables this prompt property that basically transforms the prompt class from Opik into a simple string that we could use, for example, in LangGraph. All right. And if you keep scrolling down, you will see how we have defined all the prompts of PhiloAgents as Opik prompts. Okay, we have versioned each one of these prompts. We have, first of all, the raw prompt, okay, just a string, underscore philosopher character card, for example, and we have all of this prompt here. And after that, we defined the prompt with Opik. We version this prompt, okay, and we just associate a name with this prompt with the philosopher character card. And of course, the name is philosopher character card, and then we put in the prompt attribute the prompt that we have defined here. Okay, the raw prompt, the string that we want to use as prompt. Okay, and we keep doing the same with each one of the prompts that we have defined for PhiloAgents. Okay, so now let me show you. If we go to comment again, and we go to prompt library, this is the place where each one of the prompts are going to be displayed. Let's go to some of the prompts, like for example, this evaluation dataset generation prompt that contains just one version. Okay, so let's get here and let's modify in the code, okay, something about this prompt, like evaluation dataset generation prompt, and let's, for example, delete all of this. All right, now if we redeploy, if we rerun the application like this, and we interact with a philosopher, this is the event that triggers all the LangGraph application, you will see how this version is going to be updated into version 2. Okay, so let's go here, let's go to our Phaser video game, and in here, well, let's refresh first of all. Okay, and let's talk with Socrates, for example. So let's go here. Hey, this is a video game simulation. Sorry, a simulated world. That's a change. Okay, so now if we go to comment again and we go to the prompt library, here you have it. We have version 2 of the evaluation dataset generation prompt, and if we check it, you can see that this line has been successfully erased, but that's something that is not okay. So I'm reverting back to the previous version because that's the correct one. But you can see how it works. Whenever we change one of these prompts, the version is going to be increased in this prompt library. Okay, and you can check the different versions. Like for example, check here that for the philosopher character card we have 18 versions, and that makes sense because we had to tweak a lot of things regarding the philosopher personality and the style and how the context is injected. So a lot of stuff, and it makes sense, I mean, to have these 18 versions of this prompt. And of course, this is not that much if you think about it. I mean, I can bet that for many of the prompts that you are building right now, you have hundreds of versions, right? So yeah, but you can see how it goes. Now let's go back to ScaliDraw, and let's go to the next component, the monitoring and observability component, all right? And this component is something really easy to implement as well. And remember that it is just these traces that you can see right here. If you go to the code, it's really easy to detect where we are applying this observability trace collector. You just need to go to source PhiloAgents, and inside the application, you just need to go to the conversation service, all right? And in here, just click the generate response. Inside, you will see that we have this get response, this async function, get response, and the async def get streaming response. I'm not going to cover both of these functions because they have been covered in the previous video about WebSockets and the Fast API application. But in here, you will see that we are defining an Opik tracer, right? And the Opik tracer is just accepting as parameter this graph parameter, all right? And in here, what we are passing is the graph that we are getting from the compiled workflow that we did right here in the previous line, all right? And it's just as easy as this. I mean, then we need to take this Opik tracer and to set it as one of the callbacks in the configuration that we are passing whenever we are invoking the LangGraph workflow. For example, here, you can see that we are passing the configuration, and the same goes with the streaming version of this conversation service. So, right, we have here the Opik tracer again, and we are invoking this getGraph method from the graph that we have just compiled here. And after that, we are passing this Opik tracer to the callbacks, all right? And this config is going to be passed to the A stream. Here we were passing the previous method. We were using the A invoke, the asynchronous invoke, and in this case, we are using the asynchronous stream. Remember that we needed this streaming nature to connect with the frontend, with the game UI using WebSocket, the WebSocket protocol, all right? But that's as simple as it is. If we go to Phaser again, and we start talking to some other philosopher, like Descartes, for example, sounds like interesting. Yo, nothing exists. Okay, and if we now go to Opik again, all right, you can see here the last message. So, yo, nothing exists, and the response, oops, no, it's here. The response by Descartes. So, doubter, I see you are kindred spirit, but can you be certain that nothing exists, that it's exactly the same that we saw here, right? And you have a lot of metadata. Basically in here, you are seeing the input messages, and in here, in this console, you are seeing the output YAML. It's represented as a YAML, but you can also represent it as a message. This is maybe more intuitive for us working with LangGraph, because that's the kind of response that it's generating. But yeah, you can see all of the information that LangGraph is returning about the state, the LangGraph state. This is something that we covered in episode 2 if you are interested. And here you can see all the trace spans, right? In this case, of course, LangGraph is started, the LangGraph workflow. We are running the start node. Remember that every LangGraph application starts with this __start __. This node, that defines the start of the workflow. Then we have this conversation node. This is the one that triggered the response by Descartes. And inside this conversation node, you can see that we have a runnable sequence, the chat prompt template that we are using in the chain, in the conversation chain, and here the chat grok class that we are using, because remember that we are using grok models, in particular Llama 3.3. All right, after that, there's some conditions about the tools that are not being triggered in this precise moment, but I can show you here examples where the tools have been called. Oh, so yeah, here, take a look at this. So in this case, we are just telling our agent, how can we know the difference between a human and a machine? In this case, we were talking to Alan Turing, and as a response, I'm Alan Turing. A Turing machine is a mathematical model for computation, blah, blah, blah. Okay, but the interesting thing is that in here, in the retrieve philosopher context, we are running a tool. This is the agentic RAG tool that I was telling you about in episode 2 as well, when we were defining on the LangGraph workflow. And you can see that we have information about it in this in the trace span, in this observability dashboard as well. Okay, and yeah, you can see, of course, the time it takes for each one of the operations, and also the sum of each one of the individual operations to give you an overview of how long your agents are taking to respond. You also have this information here in the duration. But yeah, I think this is really interesting. This is something for later. But yeah, I think this is really interesting when you want to add some observability layer to your agents. All right. So yeah, now that you know how to add this observability layer, I think it's time to go to the most complex part of this crash course, the data evaluation, that is composed basically of this data management, because we need to create the dataset, the evaluation dataset. And after that, we also have this evaluation, how to compute the different metrics that we are going to check to determine if our agentic RAG application is performing well or if it's performing terribly bad. All right, so let's start with the data management. So to begin with the data management, I want to, well, of course, this is the evaluation dataset creation. This is basically what we are going to talk about. And remember that you can see all your datasets, your evaluation datasets here in the dataset tab. And inside you have all of the different rows of the dataset. All right. If you click any one of them, you will see that in our case, the data is composed of a conversation, a virtual, a fictional conversation between a user and an assistant. But you will see now how these conversations are created, because it's pretty cool. So this is a diagram displaying how our dataset is going to be crafted. Okay, and it all starts with our structure, with our data structure. Remember that we saw this in episode 3 when we were covering everything related with long-term memory and short-term memory, and we saw that to retrieve, to download relevant context for each one of the philosophers, we need to download documents from both Wikipedia and also Stanford Encyclopedia of Philosophy. So we are going to follow the same approach to generate the evaluation dataset. We are going to start by downloading relevant documents about the philosopher from Wikipedia and Stanford Encyclopedia of Philosopher. We are going to apply a recursive splitter to split the different documents into multiple chunks. We are going to take a selection, a subset of these chunks, and we are going to make them pass through a LangChain chain that I'm going to show you later in the code that's going to use Grok, all right? And what is happening here is that the Grok, the big LLM, the Grok Llama 3.3 70 billion parameters, that's the model that we are going to use, is going to take the context or the chunks that we have retrieved from Wikipedia and the Stanford Encyclopedia of Philosophy, and it's going to generate high quality and realistic conversations between the user and the philosopher, all right? And then we are going to take these conversations and we are going to stack this conversation as the different rows of our evaluation dataset. You can see here that this chain is going to output these multi-turn conversations that are basically what you see here, all right? All of these messages, all of these interactions are created using Grok Llama 3.3 70 billion parameters, all right? And they are creating, grounding each one of the generations with the different chunks retrieved or downloaded from Wikipedia and from Stanford Encyclopedia of Philosophy. So that's basically it. Let me show you one last time how the diagram looks like, because I think it's pretty clear. And now we're just going to see how it works in the code. So remember that for each one of these operations, we have these tools folders that allow us to call the agent. This is a very dummy tool. This allows you to call the agent with some predefined message, but we also have the create long-term memory. This is something that we saw in episode 3. We have the delete long-term memory. We have the evaluate agent. This is something that we are going to cover in the next slide, and also the generate evaluation dataset. Okay, but now I want to warn you about something. Well, this is just the tool, the click tool, and if you go to the evaluate dataset generator, this is the class that implements all the logic that I've been explaining to you here. But before I go, let me remind you something. This generation is expensive. It's going to take a lot of time and a lot of tokens to generate this dataset. So that's the reason why we have created everything for you, and you have the evaluation dataset as a JSON here already in the PhiloAgents repository. So, I mean, you can generate one dataset, your own, and I encourage you to do that, but I'm not going to do it because I don't want to run out of tokens, but you can do it, and I will show you how to do it, okay? But yeah, let's go back to the generate evaluation dataset, and in particular to the evaluation dataset generator. And in here, I just want to focus on the call method, okay? Because this contains basically the diagram that I told you about. We start by this extraction generator. This is something that we saw in episode 3, where we are extracting all the relevant docs from Wikipedia and from Stanford Encyclopedia of Philosophy. After that, we are using the recursive character splitter that we have implemented here in this private attribute, this splitter. We can go here as an implementation, the recursive character test splitter that we are defining here in the build splitter method, and that is assigned with this private attribute, okay? We are splitting the documents into different chunks, and after that we are iterating through the chunks, through a subset of the chunks. You can see that we are just taking 4 of them. And finally, we are taking all of these chunks and we are invoking this lang chain that you can see here. This build chain is going to use chatcroc. Remember that we are using llama 3.370 billion, and we are just structuring the model as the evaluation dataset sample. Remember that we needed something like this output, and then we are just generating this chat prompt template with the system prompt, okay? And if we go back, well, I can show you the evaluation dataset generation prompt. This is the one that we modify before, but if you go to the prompt library, evaluation dataset generation prompt, you will see the prompt that we are using to generate each one of these conversations, all right, between the user and the assistant. Okay, and we just concatenate the prompt template with the model, with the chat model, and we have our chain. So now we are going to invoke our chain right here, and we have the dataset sample. All right, we assigned the philosopher ID column or attribute of this dataset sample with the philosopher.id. This is one of the class that we defined in the domain, and then we are validating the sample. And this is something that we need to do in case the format is not exactly the one that we wanted. All right, that's basically it. In case we are not, imagine that the LLM hallucinated or something like that, and it's not calling user as user, and it's saying, I don't know, person or something like that. So we need to be sure that the structure is maintained, okay? But that's basically it. I mean, we have here this this validation step, and then we have here the max samples, one condition to check the max samples, and finally we are just generating the evaluation dataset and saving the evaluation dataset to JSON, to the disk. And this is exactly the one that I'm showing you here, that you can use, of course, to follow this tutorial, or you could generate everything yourself, whatever you want. Perfect. So now that we know how the dataset is generated, as I was saying, I'm not going to run the command, but I will show you how to do it. So it's really easy. You just need to go to the makefile. Sorry, I made the same mistake again. To the parent makefile, and in here, you just need to run this make comment, okay, this generate evaluation dataset that is going to run the tool that it turns is going to use the evaluation dataset generator class. All right, but that's it. Okay, so now let's go to Scalidro again, and we are going to cover the last step, the last component of this crash course about LLMOps. We are going to check the evaluation, all right? And to do that, we are going to cover 5 different metrics: the hallucination metric, the answer relevance, the moderation, context precision, and the context recall. The hallucination ranges from 0 to 1, where 0 is a major hallucination of the LLM, and 1 is when the response is fully grounded. All right, the answer relevance ranges from 0, where the agent absolutely ignore our prompt, to 1, where the response of the agent, of the PhiloAgent in this case, is completely relevant, both to the context and also to the question asked by the user. Then we have the moderation metric that checks if the messages are toxic or offensive, right? And it also ranges from 0 to 1. Then we have the context precision that defines the proportion of the retrieved context that is relevant to the question. Okay, so suppose that I ask something to Socrates, and Socrates responds me with some information. So the context precision is going to check what proportion of the retrieved context, of the retrieved chunks that the Socrates agent has fetched from the vector database, from MongoDB, are relevant to my question. Okay, and context recall is basically the proportion of all the relevant context that is retrieved. If we keep using the Socrates example, it will mean all the relevant chunks about Socrates that are fetched when I make a question to Socrates about a specific topic, okay? Out of all the relevant chunks about Socrates, how many of them have we fetched from MongoDB? Okay, that's basically the difference between recall and precision. Okay, so now that you know there's 5 metrics that we are going to implement: hallucination, answer relevance, moderation, context precision, and context recall, we are going to see how to do it inside the code. So again, let's go to the tools folder, and inside you can see here this evaluate agent. If you go inside, you will see we are calling 2 different functions. The first one is the upload dataset. Pretty easy. It's just going to take the dataset that we stored inside the data. Remember this evaluate dataset. And then it's going to upload this dataset to Opik, okay? And to do that, it's just going to use this create dataset method that we have defined inside the Opik utils, okay? You can go here and see the different functions that we have defined, but if you scroll down, you will see we have this function defined inside our utils module for Opik. And this create dataset is going to take the Opik client. It's going to delete the dataset in case there is one dataset existing already. And then it's just creating the dataset with a name and with a description, and inserting all the different items that we are passing right here as a list of dictionaries that are basically the JSON that we have stored inside the data folder. Okay. And that's it. That's the first part of this function, this upload dataset. After that, we are just taking the dataset that we returned from the upload dataset method or function, and we are going to evaluate this dataset. And to see the implementation, you just need to go to this evaluate agent function here, and inside you will see that it's less than 50 lines of code. I think we are just taking a list of the different prompts that we are going to use. This is necessary because Opik, all the metrics that we are going to compute in Opik are computed using LLM as a judge. So there's another LLM, in this case OpenAI. That's the reason why we need OpenAI in this project. And the OpenAI models are going to serve as judges of the different metrics of the responses of our agent, and it's going to evaluate, it's going to calculate the different metric based on the agent response. Okay, so that's the reason why we also need all the prompts that we are going to use, that are, by the way, defined, of course, in the prompt library. That's also one of the reasons why we needed to define all the different prompts inside Opik. Okay, so if we keep scrolling down, you will see, yeah, the use prompts. And here, this is very important, all the different metrics that we wanted to define. The 5 metrics that I told you about. We have the hallucination, the answer relevance, moderation, context recall, and context precision. And these are just imported from Opik evaluation metrics module, all right? Perfect. Then we have some logger information here. And finally, this evaluate method that, again, is just something that we are importing from Opik, okay? Opik evaluation and the evaluate method, all right? And here we need to pass the dataset. Remember the evaluation dataset that we received, that we obtained as the return value of the upload dataset function. The task, this is something I'm going to show you right now. The scoring metrics, the 5 metrics that we want to calculate. The experiment config, this is something that we are defining here. The model ID and the dataset name, some information, some config that we need to provide to the different experiments. The task thread, the number of workers, I think in this case we were providing 2 workers. Yeah, this is it. And the number of samples that if you go to the tool, to the make file, you'll see that in the evaluate agent command that we are going to run right now, we are providing, oh no, look at this. We are using just 1 worker and we are just taking 15 samples. But of course you can increase that if you want. But yeah, so this is the evaluate, and then the prompts, as I was saying, then use prompts that are necessary to compute the different metrics. So as I was telling you, let me show you the evaluation task, because this is the asynchronous function that is going to be run and that is going to generate the response from the agent, okay? This, as the docstring says, calls agentic app logic to evaluate the philosopher responses, but it's basically, I mean, it's just going to take the philosopher factory and to create one of our philosopher class, and then it's just going to run this get response. Remember that this is the batch version of the conversational service, because we also have the streaming version that is going to be called from the game UI because we need WebSocket protocol. But yeah, this is the response, going to generate a response by the agent. And after that, we are just passing also the context that is basically the graph state from LangGraph. Okay, so we are returning the input messages, we are returning the context, the LangGraph state, we are returning the response by the agent, and the expected output message that, by the way, is going to be computed like this. Remember that if we go to commit again to the datasets, what we are doing here is that this list of messages are going to be the input messages, and the expected output is going to be this one, okay? Well, in particular, it's going to be this one right here. So what we are going to do is we are going to take all of these messages, we are going to pass all this list of messages with the philosopher context, with the philosopher style, with all of the additional information, and we are going to ask our agent, okay, what would you respond in this case with all of this context and with this list of messages, with prior messages? And depending on what it responds and matching this response with the expected output, we are going to compute all the different metrics, okay? So, how to compute the metrics? Very easy. Now that we understand the different tools that are going to be called, just remember that the evaluate agent uploads the dataset and then evaluates the agent. It's going to compute the 5 metrics. So what we need to do is go to the make file and run this make command, this make evaluate agent. And this is just going to run everything to upload, first of all, the dataset, and after that is just going to compute the 5 metrics. But that's simple. So yeah, just wait for a couple of minutes and wait until both the dataset and also the 5 metrics are computed and uploaded to Opik. So I'll see you in a while. Okay, so you can see that the agent creation is already done, and also the evaluation here in the terminal. So now if we go to Opik, you should see here in the datasets tag this PhiloAgents evaluation dataset that contains the different rows. If you click in any of the rows, you will see this conversation, for For example, in this case, it's a conversation between the user and the assistant, that is Janet, one of the philosophers that we have in the simulation. And as I was saying before this short break, this conversation is going to be used to evaluate, to generate, to compute the metrics. Okay, remember that we were taking everything, this list of messages, until the last assistant message, and then we are taking this assistant message as the expected output. Okay, and that's basically it. If you go to experiments now, you will see here that I have 4 experiments. In your case, if it's the first time that you run an experiment, you just have 1. And if you click this sourdough 585, for example, in my case, I love these kind of names, you will see here that we have the sample of the evaluation dataset that we use for this experiment, and also the value of the different metrics. Okay, here, for example, you have an answer relevance metric of 0.9, the context precision is 0.65, the recall is 0.73, hallucination metric is 0.04, sorry, I'd like to check this one, and also the moderation metric. In fact, let's check what's happening with the moderation metric, because it seems interesting that with this philosopher conversations we had something with moderation metric. So for example, 0.3. Let's see what's happening here in the conversation. So, okay, I defend the right of Robert Farrison. Freedom of speech. Oh yeah, I think it's because of this deeply offensive ideas. That's the reason why the LLM judge is taking this as offensive, which is a bit dumb if you ask me. But yeah, and this is it. If you want to check all the different a daily average of the metrics, in case you want to run different experiments like I did, like 4 experiments, maybe you want to improve some prompt, or you want to improve the retrieval in the RAG retrieval phase, you want to start changing and start adding some improvements to your agentic RAG system, then you can go to PhiloAgents, to your project, and just check these metrics, and you will see the different metrics, the average of different metrics displayed against the time. Okay, and this is really cool if you want to see how your agentic system is evolving over time. But yeah, this is everything. I hope you have enjoyed this short crash course about LLMOps. Remember that we have covered the data management, prompt versioning, the evaluation and the monitoring and observability of LLM systems and agentic systems. We have also mentioned the model deployment and the security, but these are components that I will cover in future videos in this channel. So yeah, this is everything for today. I hope you have enjoyed this video. I hope you have learned something new about LLMOps, and I'll see you in future videos. Bye bye.